So over here we have an overview and to solve tan, cos and sine equations of the forms sine theta equals k. So if we put that in our calculator, we get theta 1, our principal value. And for the sine function, we just do 180 take away theta 1. And we add or subtract multiples of 360 to generate further values from there. It might be worth also just recalling, if you haven't already, the sine graph, which goes like that. So you have 360 and it goes back to 180, and that's why we subtract the 180. And then for the cos graph, similarly for something like cos theta equals k, we put that in our calculator, get our principal value, and for similar reasons, this time we actually do 360 take away theta 1. And again, it's for the same reasons. If you go back to your cos graph, it looks like this: one complete cycle, 360 degrees. So once you know your principal value, you take away 360 from it. And finally, for tan theta, we have our principal value, and then we can add or subtract 180 degrees to generate further values. Okay, I'm going to run through 3 examples. Let's start with this one here. So we've got tan squared theta minus tan theta equals 2, and our range is from 0 to 360. First thing to do is let's bring everything onto one side. So we've got tan squared theta minus tan theta take away 2 equals 0. Now, some students might find this daunting or a bit intimidating, and we can carry on solving it this way, but let's just simplify it by saying let tan theta equals x. And notice we're in a good situation because everything is tan theta. If it wasn't, if it had a sine or a cos, I'll try and do something so all of them are the same trig function. So now I've got tan theta equals k, so you've got x squared minus x take away 2, so we've just rewritten this equation, equals 0. We can then factorize this, and so the factors of minus 2, which add up to give us minus 1, so you've got x minus 2 and x plus 1 equals 0. This solves to give us x equals 2 or x equals 2 minus 1. If we then go back to our equation, so revert back, so we know tan theta equals to 2, and put that in our calculator, we should get 63.4. We can add 180 to this, and that should give us 243.4. If we do tan theta equals minus 1, and we do the inverse tan of minus 1, we should get theta equals minus 45. But since that's not on our range, we can discard that. However, we can add 180 to this, and that should give us 135. And if I add another 180 to this, let's have a look. Theta 4, we'll get 315, which all fall within the boundaries of 0 to 360. So therefore we've got our 4 answers. Theta 1, so all our values for theta, so theta, here we go, equals to 63.4, 135, 243.4, and 315. So we've got 4 answers there. Something also mentioning is from our example we've got tan theta of minus 1 gave us minus 45. We can add, maybe it's good to see this visually as well, is by adding 180 we get to our next value, adding another 180 takes us to our next value, so that will give us theta 3 and theta 4. and from tan theta equals 2, that would just give us 63.4, and so that's theta 1, and then 180 takes us to the next point, and that gives us 243.4. Okay, in the second example, this time we've got sine theta, cos theta, and the range of values is between 0 and 360. First thing I want to do is be able to have them either all as sine theta or all as cos theta. Now we know two identities. One is sine theta over cos theta equals tan theta. The other one that's probably going to help us here is sine squared theta plus cos squared theta equals to 1. So we can therefore use this identity to manipulate our equation. And so we've got, instead of writing sine squared theta, I can write 1 minus cos squared theta equals cos theta plus 1. And we can expand the bracket. So we've got 2 minus 2 cos squared theta equals cos theta plus 1. Bring everything over onto one side. We have 2 cos squared theta plus cos theta minus 1 equals to 0. If you want, you can write this in terms of x's as well as we did in example 1. Or you could leave it as cos theta. I'll leave it as cos theta in this example. And if we factorize this, we should get 2 cos theta minus 1 and cos theta plus 1. Again, if you feel it's easier to write cos theta as x and then write this as a quadratic equation, then by all means do that. And then this gives us two values: cos theta equals a half, or cos theta equals minus 1. Again, if we solve it, we get for cos theta minus a half, we get cos theta equals half. So we put that in a calculator, we should get 60. Do 360, take away 60, gives us a second value, which is 300. And for cos theta, which was minus 1, we should get theta equals to 180. Adding, subtracting 360 to this will take us outside our range of values, which is from 0 to 360. Right, so we can illustrate our solutions to example 2 on our graph. So we've got cos theta equals a half, and taking the inverse gives us 60, and then we do 360 take away theta 1, and that gives us our second value, which is 300, and then for minus 1 we get 180 degrees. So in example 3 we've got sine 2 theta minus 35 is minus 1, and we want to be able to solve this for theta which is greater than minus 80 but less than 180. We can start just by simplifying the equation to sine x equals minus 1, and we can let x be our thing in the bracket, so we've got 2 theta minus 35. However, what we need to do if we're going to simplify is also change our range. Now we know x is 2 theta minus 35, so 2 theta would have to be greater than minus 360 and less than or equal to 360. And therefore 2 theta take away 35, which is our x, would be 360 minus 35, which is minus 395, and less than or equal to 325. So we know the range that we're looking for. So now we've changed the range by simplifying the equation. So if we take the inverse of minus 1, we know solving for x, we get minus 90 and 270, which both fall in the range. What we now have to do is convert this back to theta. So now we get 2 theta minus 35, and we know x is 2 theta minus 35, so we can do minus 90. So both these are values for x, and so therefore 2 theta equals minus 55, and for that other value it equals 305. Sorry, that's a mistake, that should be 270. Let me just correct that, there you go. And therefore our theta equals minus 27.5 or 152.5. So just to go over this, we had an equation in which, let me just take a red pen here. So you've got sine 2 theta, oops, okay, let's try again. Sine 2 theta minus 35 is minus 1, and we've got this range over here. We can simplify this. We've got a bit of a complicated input here, so we can just make it into x and let that x equals 2 theta minus 35. However, if we're going to change our x's, we need to change our range of values for theta as well. So we can rearrange this for x, and so we do 2 theta, and then we do 2 theta take away 35, and that inevitably, that's the same thing as x. So now we can solve for x within this range over here. If we solve for x, we get minus 90, or we get 270, and we can, if we add or subtract 360 to either of them, we'll go outside the range. So those are the only two values that we got. If we then, so we know our x's, we can now convert back to theta. So 2 theta minus 35 is that, and then we add 35 to both sides, and we get these values here, and then you divide both values by 2, and you get your theta 1 and theta 2. Okay, so here's two exercises. What I suggest you do is stop the video, have a go at these exercises, and then play it once you've done them to check your answers. So let's start with part A. We've got 2 cos squared theta minus cos theta minus 1 equals 0, and we're solving it between 0 and 360. You could, if you wanted to, say let x equals to cos theta, because we'll need to sort of factorize and simplify this expression. So we end up with 2x squared minus x minus 1 equals to 0. We can then factorize this expression, so factors of minus 2, which add up to give us minus 1, and we should be able to factorize this to 2x plus 1 and x minus 1 equals to 0. This gives us two solutions. It gives us x equals minus a half, or x equals to 1. If we then convert back to cos theta, so therefore cos theta equals minus a half, or cos theta equals to 1. If we put our value into our calculator, we should get theta 1 equals 120. We do 360, take away that, and our theta 2 would give us 240. And then for cos theta equals to 1, we can see from the cos graph straight away that we should get theta 3 equals 0, or theta 4 equals 360. So we have 4 solutions there. 1, 2, 3, and 4. Okay, so for part B of the exercise, so we've got sine squared theta minus 30 equals a half. We can start just by getting rid of that square sign. So we've got theta minus 30, and whenever we take the square root, we have two values, a positive and negative, and so we've got square root of a half. So you've got two possible values there. Now, as in example 3, you could, if you wanted to, also just simplify the input. So you've got sine of x equals plus or minus a half. It's got two values, and where x equals theta minus 30. This will inevitably give us some new limits, so we can write x is greater than or equal to 0 minus 30 or less than or equal to 330. So for our positive value, so for sine x equals 1 over square root of 2, the positive value, we should get x equals to 45, and then since it's sine, it will be 180 take away 45, and then so our x2 would give us 135. And for our negative value, where you've got sine x equals minus 1 over square root of 2, if we put that in our calculator, we should get x give us 225, and then we should get for our fourth value 315. Maybe I should just add that if we put minus 1 over square root of 2 in our calculator, we get minus 45 as our first value, and then 180 take away minus 45 gives us a 225. The minus 45 doesn't count because it's not within the range of values that we're considering, and so we can add 360 to the minus 45 to give us our 315. And again, we can check these values going back to the sine curve and seeing that the 225, which is somewhere over here, and you've got 315, and then the minus 45 is about over here. Right, so once we've got that, we know from our equation where x equals theta minus 30, we can convert our x values by adding 30 to them to give us our theta. So theta 1 should give us 75. Theta 2 will give us 165. Theta 3 gives us 255. Theta 4 gives us 345. So those are our four values for theta.